Hydrocarbons. A hydrocarbon is any of a class of organic chemicals made up for only the elements carbon and hydrogen. The carbon atoms join together to form the framework of the compound and the hydrogen atoms attached to them in many different configurations. Hydrocarbons are the principal constituents of petroleum and natural gas. They serve as fuels and lubricants as well as raw materials for the production of plastic, fibers, rubbers, solvents, explosives, and industrial chemics. There are different types of hydrocarbons. 19th century chemists classified hydrocarbons as either aliphatic or aromatic on the basis of their sources and properties. Aliphatic, from Greek aliphar or fat, hydrocarbons deliver from the chemical breakdown of fats or oils. They are divided into alkanes, alkenes, and alkynes. Alkanes have only single bonds. Alkenes contain a carbon-carbon double bond, and alkynes contain a carbon-carbon triple bond. Aromatic hydrocarbons make up a group of related substances obtained by chemical breakdown of certain pleasant-smelling plant extracts. They are classified as either arenes, which contain a benzene ring as structural unit, or as a non-benzoate aromatic hydrocarbons, which possess a special stability but lack a benzene ring. Hydrocarbons make up fossil fuels. One of the main byproducts of fossil fuel combustion is carbon dioxide, CO2. The ever-increasing use of fossil fuels in industry, transportation, and construction has added large amounts of CO2 to the Earth's atmosphere. Atmospheric CO2 concentrations fluctuated between 275 and 209 parts per million by volume of dry air between 1000 CE and the late 18th century, but had increased to 316 ppmv by 1959 and rose to 412 ppmv in 2018. CO2 behaves as a greenhouse gas. That is, it absorbs infrared radiation emitted from Earth's surface and radiates it back to the surface. Thus, the substantial CO2 increase in the atmosphere is a major contributing factor to human-induced global warming. Fossil fuels are used to produce energy. In the home, they are burned to produce heat. In large power stations, they are used to produce electricity, and they are also used to power engines. The bonds between hydrogen and carbon atoms store energy by burning their compounds in presence of oxygen. The bonds are broken, and the stored energy is converted to heat energy from forming carbon dioxide, CO2 in the process. Fossil fuels are non-renewable. This means that their supply is limited and they will eventually run out. Fossil fuels formed by the decomposition of plants and animals from millions of years ago. This is why they are called fossil fuels. They are burned to produce energy. In large power stations, they are burned in the presence of oxygen. As the fuel burns, the heat energy is used to heat water. As it is heated, it produces steam, which turns, rises, and drives a turbine. The energy conversion goes from chemical energy stored in the fuels to heat energy as it burns, which is converted to kinetic energy as it drives large turbines, and finally, it's converted to electrical energy. The problem with burning fossil fuels is their effect on the environment. As mentioned, fossil fuels are hydrocarbons. When a hydrocarbon is burned in the presence of oxygen, it releases carbon dioxide into the atmosphere. Carbon dioxide is a greenhouse gas and is leading the cause of global warming. On the other hand, we have renewable energies. Renewable energies are sources of clean, inexhaustible, and increasingly competitive energy. They differ from fossil fuels principally in their diversity, abundance, and potential for use anywhere on the planet, but above all they produce neither greenhouse gases, which cause climate change, nor pollen emissions. Their costs are sources of falling at a sustainable rate, whereas the general cost trend for fossil fuels is in the opposite direction in spite of their present volatility. Growth in clean energies is unstoppable. As reflected in statistics produced annually by the International Energy Agency, IEA, they represent nearly half of all the new electricity generation capacity installed in 2014, when they constitute the second biggest source of electricity worldwide behind coal. Clean energy development is vital for combating climate change and limiting its most devastating effects. 2019 was the second warmest year on record. The Earth's temperature has risen by an average 0.85 since the end of the 19th century, states the National Geographic in its special November 2015 issue on climate change. Renewable energies received important backing from the international community through the Paris Accord signed at the World Climate Summit held in the French capital in December 2015. The agreement, which entered into force on 2018 established for the first time in history a binding global objective. Nearly 200 signatory countries pledged to reduce their emissions so that the average temperature of the planet at the end of the current century remains well below 2 grades centigrade, the limit above which climate change will have more catastrophic effects. The aim is to try to keep it to 1.5 grades centigrade. The transition to an energy system based on renewable technologies will have very positive economic consequences on the global economy and on development according to the International Renewable Energy Agency, IRENA, doubling the renewable energy share in electricity generated to 57% worldwide by 2030 will be necessary for meeting the Paris Agreement targets. This requires raising annual investments in renewable energy from the current USD 330 billion to USD 750 billion, thereby boosting job creation and growth linked to the green economy. As a conclusion, I would like to highlight the importance of the change towards the use of renewable energies for an economic, social, and environmental well-being, as well as the support towards these new forms of producing clean energy based on resources that are infinite. I would like to thank for your attention and interest in these topics. Thank you very much for watching this video.